Hello everyone, welcome to lesson 4-2, compare and order rational numbers. For this lesson, we're going to be looking at the vocabulary rational number, common denominator, and least common denominator, or LCD. Okay, let's start with our vocabulary startup. What is a rational number? A rational number is a number that can be expressed as a ratio of two integers written as a fraction. So it can be a fraction, right? A comparison of two numbers as well, in which the denominator is not zero. The reason is because anything divided by zero is zero. The Venn diagram below shows that the number 2 can be called many things. It is a whole number, integer, and rational number. The number -1.4 bar notation, essentially because it's bar 444 repeating itself infinitely, that's what the three dots mean, is only a rational number. Common fractions, terminating and repeating decimals, percents, and integers are all rational numbers. So make note of that. What is a rational number? All these are considered rational numbers. So let's work on this Venn diagram. I would recommend that you copy this down carefully. We've been given a number bank here on the right hand side with a list of numbers, and we are supposed to place these numbers where they go on this diagram. So write the numbers from the number bank on the diagram. We have decimal 8. Now decimal 8, this is part of a number. This is not a whole number. It's only a fraction of a number or a decimal. That is considered a rational number. So I would write decimal 8 right there with rational numbers. Since we did a rational number, let's look for other rational numbers. We know that a rational number is part of a number, just like this, part of a whole. Here's another part of a whole. It's not quite 2, it's 1 2/3. So that's also another rational number. I'm just going to put it right here next to it. And then there has to be another rational number because I have a space right here for another rational number. A rational number is also a decimal. And this is a decimal that repeats. That's called a bar notation right there on the top. And because it repeats, it's following a pattern. That makes it rational, since it's following a pattern, 2, 2, 2, 2, infinitely. So that would also be considered a rational number. Okay, and then we have whole numbers. Whole numbers are numbers that are not part of a number, like 1, 2, 3, 4, 5, 10, 20, and so on. And there it is. We have 1 right there. And finally, a whole number that is a negative or positive. Okay, there it is. It's considered an integer. Okay, in integers, we could also have 3. We could have 6. They could be positive as well, because integers are also whole numbers. Okay, but integers cannot be considered whole numbers. Okay, integers are not whole numbers, but whole numbers are integers, and integers are rational numbers. But rational numbers, like a half, this is not considered an integer. It's a rational number. Okay, make sure you have this example copied down. Now let's look at a real worlding. Not all numbers are rational numbers. The Greek letter pi represents the non-terminating and non-repeating number. Non means not, right? And terminating means finishing. So this means not finishing or not ending, and not repeating number whose first few digits are 3.14. Now 3.14, and you see how it has the 3 dots right there? That means it continues on. The number is not done. This number is an irrational number, so not rational. Let's look on the internet to search for the digits of pi, and let's write them down over here. If you type pi or pi into Google, you will get 3.14159265359 ... Okay, you see that there is no rhyme or reason, no pattern here. It's not repeating itself. I mean, this 59 repeats itself over here, but it doesn't necessarily mean that the next number is going to be a 2, like it is here. It doesn't repeat itself, ever. Okay, actually, and you can see here that before the 5 is a 3. Here, before the 5 is a 1. So there's no repetition, and there's really no pattern. So it's considered an irrational number, the number pi. Pi is used when we're working with circles. So if you're working with circumference, or if you're working with the area of a circle, we need to know pi. Pi is essentially an average of the circumference, how the diameter and circumference compare to each other. So if you have a circle, right, the distance across the circle is called your diameter. If you take that distance, that measurement, let's say that's 2 centimeters, right? If you take that distance and you multiply it by 3.14, you will get this distance, the circumference. So diameter times 3.14, or diameter times pi, will give you the circumference. For this lesson, we're going to be comparing rational numbers, so comparing fractions and seeing which one's greater or lesser than. So this is one of the key points to this lesson. Compare rational numbers. A common denominator is a common multiple of the denominators of 2 or more fractions. A denominator, everyone, is the bottom number of a fraction. So if it's a common denominator, it means it's a common multiple that both numbers can have. For example, if I have over here number 1/8, right? And I also have another fraction where I have 3/4, right? 3/4. A common denominator, these are the denominators. My denominators are 8 and 4, the bottom numbers. But a common denominator is a number that when I count by 8s and when I count by 4s, they're both going to have the same number. So if I count by 8, the first number I say is 8, right? 8, 16, 24, and so on. The first number is 8. When I count by 4s, 4, 8. 8 is the second number for 4. So the common denominator would be 8. What did I do to this 8? Nothing. So I don't do anything to this 1. So I keep that as 1. Now let's just say I was adding these two, right? Let's pretend I was adding those two fractions. What did I do to this 4 to make it 8? I multiplied it by 2, didn't I? It was the second one. 4, 8. So I multiply that by 2. I need to do the same to the top. So I multiply the 3 by 2, and I get 6. So when I add 1/8 plus 3/4, I'm going to get 7/8. You see? So you keep the bottom out of 8. So to keep reading, that's what a denominator, a common denominator. The least common denominator, or the LCD, is the least common multiple, or LCM, of the denominators. You can use the LCD to compare fractions. You can also use a number line. Here is a number line example. Okay? We drew out a number line that goes from -1 down to -2. See? And the 0 will be around here somewhere. And then we wrote -1 and 1/6, -2 and 2/6, -1 and 3/6, -1 and 4/6, -1 and 5/6, -2, and so on. So this whole number right here, from here to here, is divided into 6 parts. And the reason they're doing that is because we're working with 1/6. So they broke the whole into 6 parts. So fill in the blank with less than, greater than, or equal to make -1 and 5/6 and -1 and 1/6 a true statement. A true statement means you're completing the statement. Is it less than, greater than, or equal to in here? Graph each rational number on a number line. Mark off equal size increments of 1/6 between -2 and -1, right? Because we broke the holes into 6. You see, these are broken into 6. This is 5/6 and 1/6. And when we use the number line, -1 and 5/6 is right here. Okay? And then -1 and 1/6 is right here. Remember that 0 is here. And in that direction, we have positive numbers. So really, as the numbers go this way, in this direction, they decrease. They're worth less. So -1 and 1/6 is a bigger number than -1 and 5/6. So what do? We say that this number is less than. Right? And you can see that right there. Okay, let's try it now. Here we have, use the number line to compare -5/6 5 and 5/9, and negative 5 and 1/9. So the numbers are being broken up into 9 parts. So we need to write this out and break it up into 9 parts so that we have 1/9, 2/9, 3/9, and so on. Okay, with the negative 5. Once you have that, label it and see which number is bigger or smaller. Now, without even using the number line, you can tell that 5 is greater than 1. Because they have the same denominator, they're the same style of fraction. They should fit together. So because you realize that negative 5 here is going to be less than negative 1, right? The negative 1/9. So you can already tell. But go ahead, pause the video, draw a number line, and label it, and then make the statement true. Okay, I hope you paused the video and tried it on your own. First thing I've done is I divided my whole from negative 5 to negative 6 into 9 parts. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That would mean that this number here is negative 5 and 1/9. This one here would be negative 5 and 2/9. This one would be negative 5 and 3/9. And so on. So we have for all of them. Then when it gets to negative 5 9/9, it's just simply negative 6. Now I'm going to go ahead and label negative 5 and 5/9 right here, and negative 5 and 1/9 right there. Now remember, the numbers are increasing as we move to the right, right? Because it'll be negative 4, negative 3, negative 2, 0, and then it'll get into the positives. So really, this number is larger, or has a greater value than this number. So we're going to say that it's less than, right? Negative 5 and 5/9 is less than negative 5 and 1/9. Let's try example 2 now. Fill in the blank with less than, greater than, or equal to make 7/12 and 8/18 a true statement or true sentence. So which one's greater than, less than, or equal to here, right? What we do is, in this method of doing or completing this question, is to find the lowest common denominator, okay, for the two numbers, for 12 and 18. So for 12 and 18, let's count by 12s and let's count by 18s. So if I count by 12s, I would get 12, 24, 36. If I count by 18s, the first number is 18, the second one will be 36. There it is. That's my lowest common denominator, the first denominator or the first number they have in common. So now I have to look at, what do I do to that 12 to make it 36? Well, times 3, right? 1, 2, 3. So 12 times 3, whatever you do to the bottom, you must do to the top. 7 times 3, it turns into 21/36. What did I do to the 18? The 18, I multiplied it by 2. See? 1, 2. It's the second one in the sequence. So 18 times 2 is 36. And then whatever you do to the bottom, you must do to the top. So 8 times 2 is 16. So now we have 21/36, 16/36. Clearly, 21/36 is larger. So what we say is 7/12 is greater than 8/18. Okay? And there you have it. Now that you saw me complete that question, go ahead and try BCD on your own. And when you are done, pause the video and see if you did it correctly. Sorry, play the video and see if you did it correctly. Right now, you will pause the video. Pause now. I hope you paused the video. Let's try B. So when we do B, this method is finding the least common denominator. So when we count by 6 and we count by 9s, 6, 12, 18, I get 18 for both numbers, 6, 12, 18, or 9, 18. Again, what did I do to the 6? I took the 6 and I multiplied it times 3 to get 18, right? So I must do the same to the 5. Up here, I must do the same to the 5. So what's 5 times 3? 15, right? And, oh, sorry, the way I do it, I just do it all into one big fraction because it's the same denominator. It's out of both, so I have 15. And then what did I do to the 9 to make it 18? Multiply it times 2, right? 9 times 2 is 18. So 7 times 2 is 14. And you can see here the answer is 15 is greater than 14. So 5/6 is greater than 7/9. Let's try C. Again, I'm going to look for a common denominator. And I can tell already that it's going to be 50. Because if I count by 50s, the first number is 50. If I count by 5s, my 10th number will be 50. So my common denominator is 50. What did I do to the 5 right here to make it into 50? 5 times 10, right? So I have to do 1 times 10. And 1 times 10 is simply 10. And what did I do to this 50 to make it 50? Absolutely nothing, so I do nothing to the 7. And which number is greater? Well, 10 is greater than 7, right? And that's my answer. 1/5 is greater than 7/50. Okay, now let's try the denominators 16 and 10. Now, one thing you have to keep in mind is both of these are negative rational numbers. There's a negative and a negative. Remember, the larger the negative, the less the value, or the lesser the value. Or the larger the negative number, the smaller the number really is. Don't forget that. Okay, what is the common denominator between 16 and 18? If I count by 16, once I get to 5 of them, so 16 times 5, I get 80. And I believe that is my common denominator because I also can multiply 10 times 8 and I get 80. So 16 times 5 is 80. 9 times 5 is 45. Remember, it's negative 45. 10 times 8 is 80. 10 times 8, 7 times 8. So they both be multiplied by 8. 10 times 8 is 80. 7 times 8 is 56. So 56. Negative 56, right? So the bigger negative number is the lesser value. The smaller negative number is a bigger number. So our answer here will be negative 45 is bigger than negative 56. It's greater than. So there's our answer right there. Now let's look at a word problem. Example 3. In Mr. Huang's class, 20% of the students own roller shoes. In Mr. Trevino's class, 5 out of 29 students own roller shoes. I'm assuming these are the shoes that have the wheel on them, and you can glide on the floor if you put all your weight on your heel. In which class does a greater fraction of students own roller shoes? Okay, 20% needs to be changed to a rational number such as decimal 2 or 2/10 or 1/5, right? We need to change that. We'll convert it. Express each number as a decimal and then compare. So see, now we're going to change them all to decimal. So we change the percentage to a decimal, and we're going to change the 5 out of 29 into a decimal simply by dividing the 5 divided by the 29. You see, 5 divided by 29 is about decimal 1724. And over here it's decimal 2. So this is like saying 20, and this is like saying 17. Which number is larger? 20, right? So when you compare, you can say that Mr. Huang, the 20%, they own more roller shoes. Okay? Let's see another word problem. If you understood how to do that, please pause the video and try E on your own. Pause now. Okay, I hope you paused the video. In a second period class, 37.5%, 37.5%, if you know how to count by 12.5 or by 1/8, you know that this is 3/8, right? Because 1/8 is 12.5, 2/8 is 25, 3/8 is 37.5. You're essentially counting by 12.5 each. So this is 3/8. So 37.5 of the students like to bowl. In a fifth period class, 12 out of 29 students like to bowl. In which class does a greater fraction of the students like to bowl? Let's convert both of these numbers into decimals. So we already have 37.5%. To change that into a decimal, you just simply divide it by 100, which moves the decimal twice to the left, like so. And it becomes 0.375. And for 12 out of 29, we write it as 12 out of 29, which means we have to divide the 12 on the top divided by the 29, which would be approximately, and I say approximately because I'm not going to write down all the decimal places, it's too many, 0.4137. 7. So it's about 0.41, right? So which is greater? 0.37 or 0.41? Well, 0.41 is greater, right? So we can write it as so. Let me delete some of this stuff here. Or actually, I'll just write it just below here. I'm going to write it right there. So my final statement, or the true sentence that I want to write, is that 37.5% is less than 12/29. For our second key point, we're going to look at ordering rational numbers. So you can order or put in order from least to greatest, or from greatest to least, however you're ordering it. You can order rational numbers using place value. So your units or ones, your tenths, hundredths, thousandths, and so on. So let's look at that example. For example 4. Okay? Let's look. They want you to order the set of number 3.44, so this is like saying 44, pi, which is 3.14, and it continues on with other numbers, and then 3.14 with terminating, the next number will be 0, and 3.444444 continuously. We have to look at the place value. So for example, this number here is the first number, 440. You know that, right? Pi continues. Remember the example that we had originally for pi in the first example? For the first example, we had pi was 3, I'll write it in a different color so we're not confused. This is pi, 3.14. I can't quite remember if it was 3.141. Okay? That, and then 1592, so on. It keeps going, but I'm going to stop at the 1. And then we have 3.14. Okay, 3.14 right here. Right? Pi is the green one. And this is our blue one right here. 3.44. And then we have, finally, I can do the last one, I guess, in yellow. Okay? 3.444 continuously. And they want us to order it from least to greatest. So you just base it on the next number, on the thousandths. On the thousand. Oh, what's here, by the way? I hope you're thinking what I'm thinking. Because it's terminating, it's a 0. So now it's easy, right? Using place value, it's easy to know which one's the least. So this is 44, while this is 141, and this is 140. So clearly, here is our smallest value. The red is the smallest value. Then it goes 141 with our green value. And then it jumps up to 44. So we have 440 or 444. Continuing. 440 will be smaller, right? The 440 is smaller. And then finally, 4444 is the largest. So as you can see, they've shown you that down here. Okay, same way that I just put them in order for you. Smallest, second smallest, third smallest, largest. They're right there. Okay, now that we use place value, go ahead and do the same here. But notice that they're not in the same format. You have to change them all to the same format. You can change them all to decimals, or you can change them all to percents, or you can change them all to fractions. Whatever you see fit. I would change them all to decimals. Go ahead, pause the video now. Okay, I hope you paused the video. 23%, we'd have to divide it by 100 to make it into a decimal, and it becomes 0.23. Okay, there's my first one. Then we also have 0.21. There's my second one, right? 1/4, or 1/4, as you hear it, like the coin, 1/4. If you wanted to make it out of a whole 100, right? What did I do with the 4 to make it 100? I multiplied it by 25. I must do the same to the top, and it becomes 25 hundredth, or 25 in the 100th place. 0.25, 25 hundredth. That's 1/4. We do the same with the 1/5. 1/5 To bring it up to 100, which is a whole, I have to multiply 5 times 20. Do the same to the top, and it's 1 times 20, and it becomes 20 hundredth. 20th hundredth. 0.2, and the next number would be a 0. But we don't include a 0 in a terminating decimal. We just simply make it 0.2, and we assume that everything after that is zeros, right, for all the numbers. Now we can go ahead and put them in first to last. The lowest number is the 20, right here, 20. So that's my lowest. That's my first number. First. And then 21 will be my second. And 23 will be my third. And finally 25.25 will be my highest, which is my fourth, my highest number. And there you go. Now, to write it properly, you would have to write it in these formats. So let's start with 1/5. Then we have 0.21. Then we have 0.23 or 23%. And then finally 1/4. And that's how it should be written, from least to greatest. And finally, example number 5, where we're converting all our rational numbers into decimals. We are taking our percentages, our fractions, and so on to compare. Nolan is the quarterback on the football team. He completed 67% of his passes in the first game. He completed 0.64, 3/5, and 69% of his passes in the next 3 games. List Nolan's completed passing numbers from least to greatest. 67%, I already know it's 2/3. Because if you take 100 and you break it up into 3 parts, you're going to get 2 parts. 1 part is 33%, 2 parts is 66%, and 3 parts is 99% or 100. But it's bar notation, so 66.666% gets rounded to 67. So that's 2/3. This is less than 2/3, but this is more than 2/3, because these become 0.67, this becomes 0.69. A 3/5 is 0.6, right? Because you make this 10, and if you make this 10 by doubling it, you have to make this 3 by doubling it. And here it is. You can see it for yourself. Okay? And there you go. They put it in the right order with the right format. Okay, we'll work more with that in class. For now, take a look at the guided practice. Make sure that you feel comfortable with this content. If you do not understand how to do any of these, go back to the examples on the video, rewatch it, and make sure you feel ready for class. See you then, everyone.